that. All right, it's gone. All right, so what we're going to be talking about first is going to be resistance. There's going to be pulmonary resistance. There's only going to be 3 ways in which you can have a change in pulmonary resistance. So the first way is going to be, it's going to be based on cardiac output. So what happens? Heart starts to pump more. There's going to be more blood that's going to your blood vessels. And the way that your lungs are arranged is that some of them are being used at any one point. And sometimes when cardiac output increases, they recruit other ones. Remember when Dr. Hammerl used to tell us, it's like, oh, in the heart, you do not recruit more blood vessels. Well, in the lungs, that's what he's really comparing to. In the lungs, you do recruit more blood vessels, and then as you increase the amount of blood vessels that are being recruited, what do you think happens to resistance? Resistance goes down. So resistance goes down when you increase cardiac output. That's number 1. Number 2, pulmonary resistance due to lung volume. So this is basically what happens. You have your alveoli. Your alveoli looks like this. And what you have is you have these blood vessels that are going around. Oh, I should make them a different color so that's a little easier to see. So you have your alveoli and you have your blood vessels. Your blood vessels are coming around your alveoli. And let's imagine when you increase your lung, you expand your lung. So you breathe, you took a really big breath, big breath, and then your alveoli starts to expand. When it starts to expand, what happens is it pushes against these blood vessels, and then this blood vessel gets compressed. And it gets compressed to a point where there's only this much, there's very little amount of blood that will go through it because you're pushing against your alveoli out. So in this case, when you're taking a really deep breath in, what happens to your resistance towards the end of your breath? It increases your resistance because your alveoli gets really big and starts to compress those blood vessels. Their resistance is about how easily it gets through your blood vessels. So this is what happens in high lung volume. Let's say you took a really deep breath out. When it goes out, your alveoli obviously is going to be, I say alveoli, so if it makes you think of raviolis, I'm sorry. All right, so when you breathe out, your alveoli gets smaller. So what happens, do you think, will happen to the blood vessels in this area? What happens? Is there more room for the blood to go, or is there less room for the blood to go? There's more, because there's more space, because the alveoli is not really pushing against your red blood cells anymore. On the other hand, there's something else. There's this part over here, I'm going to just highlight over here, that is, it's called extraalveolar. Vessels. And these extraalveolar vessels, they're attached to the wall. So let's imagine that this is the wall of your chest wall. This is chest wall. And there's a little spring here that is kind of attached to your red blood, to your vasculature. Let's say that's the normal situation. Let's say if you breathed out, what happens to your chest wall? It comes out, right? Comes out. What happens to that spring? Spring gets stretched out. If it gets stretched out, what happens to that blood vessel? it's going to make it bigger, right? It's going to pull it out stronger. So in that case, what happens when you take a deep breath? When you take a deep breath, your chest wall is moving this way. It's reducing the resistance. But what if you breathed it in? If you breathed in, your chest wall is getting smaller. So what happens to that spring? That spring isn't doing as much work anymore. So what happens to those vessels? What happens to those vessels? Yeah, those vessels are going to collapse. So the extra alveolar vessels over here, in low lung volume, your resistance increases. High lung volume, what happens? Resistance increases again because of your alveolar vessels over here. So resistance increases. So the important thing to know is how they're going to show you this on a graph. So the way that they're going to show you on the graph is a graph that kind of looks like this. And on your x-axis over here, you're going to have lung volume. And then on your y-axis is going to be resistance. And if you look at this, this makes a lot of sense, because as you breathe all the way up to your highest amounts, you're going to have a lot of resistance. Why? Because at high lung volume, you have resistance at the alveolar blood vessels. When you are at low lung volumes, you have a lot of resistance at your extra alveolar vessels. So my question is, what is this point over here? This is the least amount of resistance. This is your FRC. Any questions? All right. Next thing, pulmonary resistance due to hypoxic vasoconstriction. Imagine this is your alveoli, and here's another alveoli over here. Looks like a bunch of grapes, and you have this blood vessel that comes along, and then it takes care of both of these alveoli. Now, in the situation that you have you have no oxygen in one of these alveoli. So like, let's say this was blocked. If this was blocked, what will happen inside this alveoli? It would have a lot of oxygen, or it would have very little oxygen. It would have very little. So what your body does is that it closes off these blood vessels. This way, your blood vessels you're not sending blood to places where there's no oxygen. So the clinical correlate to this is in fetal circulation. So in fetal circulation, you're going to see this a lot in block 3, so I want to just show you a good way of depicting heart stuff. So this is going to be your right atrium, this is going to be your left atrium, this is going to be your right ventricle, this is going to be your left ventricle. And what happens is you have input of blood going through the vena cava. It goes into your right atrium, and then typically what happens, it goes into your left atrium over here. Left ventricle, sorry. And then it goes into your lungs, and then it goes around to your left atrium over here. And then it goes to the left ventricle and comes out. All right? This is just a way of depicting it really quickly. Where is ductus arteriosus? Ductus arteriosus is here. This thing over here is ductus arteriosus. Same exact thing over here. This is right atrium, left atrium, right ventricle, left ventricle. So typically, what happens in a baby? In a baby, your blood is going to go into your right atrium, right? You have a foramen ovale at the right atrium and left atrium. Blood will go from your right atrium, goes down, goes to your left ventricle, goes to your right ventricle like this. And then what happens after that? The next step is that it comes down over here. It leaves both the great vessels. Now, here's the thing. When you're a baby, how much oxygen do you have in your lungs? 0. You don't have oxygen in your lungs. So what will happen? Vasoconstriction. When vasoconstriction happens, this part doesn't perfuse very well. So there's very high resistance here. Which way will blood go? It wouldn't go in that direction. It would go through your ductus arteriosus. And that's the reason why blood goes into your ductus arteriosus in the first place. It goes into your ductus arteriosus because your pulmonary vasculature is all vasoconstricted because there's no oxygen in it. What happens when the baby comes out? When it comes out, you start to have oxygen. What happens to this stuff over here? It's going to clear off. It's going to vasodilate again. And when it vasodilates, does blood want to go through this small ductus arteriosus? Lungs have very low resistance. It will preferentially go the other direction towards pulmonary circulation. And then ductus arteriosus and PGE and everything like that, you'll probably get that later on with heart stuff. But this one will block off, and then your blood will go to your normal way where it goes right atrium, left ventricle, or right ventricle, going around pulmonary circulation, left atrium, left ventricle. So that's the clinical correlate for hypoxic vasoconstriction. Any questions so far? Okay. Let me do this.